So how can we convert from polar to rectangular and polar? Well, polar is in terms of r's and thetas, and rectangular in terms of x and y. And so just like in trig in your unit circle, you had an r and you had a theta, but believe it or not, those were related. So you started dropping a perpendicular and said, okay, this side's x, this is y, and then we created a right triangle, and we actually defined some of our trig functions in terms of that. Let's see, how could I rewrite x's and y's in terms of r's and thetas and vice versa? Well, let's see, we know that r squared is going to be x squared plus y squared because that's the Pythagorean theorem. Over here, we learned that cosine theta was defined to be x over r, or we could rewrite that and solve for x and say x equals r cosine theta. That should be somewhat familiar when we did vectors. We also defined in trig that the sine of theta is the opposite over the hypotenuse, and again cross multiplying. We know that y is equal r sine theta. So if we're given r and theta, we can find x or y. Over here, if we're given x and y, we can get r, but I need to know how to find theta. Well, there's a couple of different ways, but the easiest way is to look at it and say, well, the tangent of theta is opposite over adjacent. And that's just using x and y. But I don't want the tangent of theta. I need theta. So that would be the inverse tangent of y over x. And again, that should be very familiar when we were doing the vectors. So using those formulas, we need to do some conversions. So we're asked to convert the point from rectangular coordinates into polar. So this is x and this is y, and we're limited that r has to be positive. That's kind of nice. But theta is in radians, all right? So I don't want degrees, I need radians. So let's see, if I need r and theta, I'm given x and y and I need r. So I know r squared is x squared plus y squared, and I know theta is the inverse tangent of y over x. So r squared is those values squared. So we have 4 plus, let's see, 4 times 3 is 12. And r, the square root of that, is 4. Now don't worry about the plus or minus because they told me that r was positive. Now what about theta? This is where you've got to be very careful. What if I were to plot that? Okay, this is x and y. What quadrant would I be in? Well, I would be negative and negative. I would be in the third quadrant. So if I want an angle, that angle is going to be bigger than 180 degrees or bigger than pi. I would have theta equals the inverse tangent of y over x. Now yes, you can pull out your calculator if you want, but if I reduce that, I'm just going to get the square root of 3. Now I'm supposed to know what that is. Well, just in case you don't, turn on your calculator, and I'm going to leave it in degree mode. So if I have the inverse tangent of the square root of 3, look at what my calculator gives me. It gives me 60 degrees. Now even if I converted that to radians, I would be wrong. I would be wrong because I'm in the third quadrant. Okay, your calculator's giving it to you up here at 60 degrees. So all the way over there, what am I going to add? 180 degrees. So theta is 240 degrees. Is that correct? Well, it's better than 60 degrees, but it's still wrong because I need theta in terms of radians. Well, what's 240 degrees in terms of radians? I'm going to let you think about that. 4/3 pi. So r is 4 and theta is 4/3 pi. And that's the answer I'm looking for. Okay, so you've got to be careful about your quadrants and be careful about what theta is in. Let's do this example. Now this is x and this is y. So r squared is, so r is ugly square root of 13. Okay, we're just going to leave it like that. Now, tangent. So theta is inverse tangent of y over x. Now that is not one of the angles I know from trig. Let's again check what quadrant I'm in. If I go -3 and +2, I'm in the second quadrant. So let's go ahead and pull up that calculator. So you can leave it in degree mode. So let's see what happens. Inverse tangent of 2 divided by -3. The calculator tells me -33, let's call it -33.7 degrees. That's not in the second quadrant. What's the calculator doing? It's telling me down here. So again, I have to be over here. So I have to add 180 degrees. I'm going to say plus 180 degrees. Is that the right answer? So is theta going to be 146.3 degrees? Well, that is in the second quadrant, but again, it's not in radians, right? So I need that to be in radians. So you can either convert that or, so what I would prefer you to do, put your calculator radian mode, take that inverse tangent of 2 divided by -3, and it's going to give you a negative angle. You should know that's in quadrant 4, so I need to add not 180 degrees, but I have to add pi radians. That is in the second quadrant. That's the answer I'm looking for. Another thing you can do is you can take your answer and multiply it by pi over 180. All right, so we could take the, let's see, 146.3 times pi divided by 180. That's just your conversion factor, and again 2.55. Either way, you've got to make sure your answer is in radians, right? That's what the directions say. So we have r is the square root of 13 and theta is 2.55. Now we're going to convert from polar to rectangular, and that's usually a little bit easier. We have x equals r cosine theta and y equals r sine theta. Remember, this is r and that's theta. So we have x equals 5 times the cosine of 300 degrees, and we have y equals 5 times the sine of 300 degrees. Now you should know what those are, but in case you don't, you can use your calculator. Our mode needs to be in degree mode because those are our angles. So we have 5 times the cosine of 300 degrees, and that's 2.5. And y is negative 4.33. Does that make sense? What quadrant are you in? Think about, have you rotated? Where's 300 degrees? That's the fourth quadrant, positive 5, and this is the fourth quadrant. Okay, so yes, you should know what 300 degrees is, you should know what 5 pi over 6 is, but again, decimals are fine. So here we're going to have x equals negative 4 times the cosine of 5 pi over 6, and y equals negative 4 times the sine of 5 pi over 6. So our mode this time needs to be in radian mode. So we have negative 4 cosine of 5 pi divided by 6. Then we have negative 4 times the sine of 5 pi divided by 6. So this tells me I am in the quadrant 4. If I were to plot that, you should end up in quadrant 4. Alright, the last example. That looks weird. Remember, this is R and this is theta. Since you don't see a degree symbol, that's in radians. Okay, you know it's in degrees when you see that degree symbol. So x is R cosine theta. So that's going to be 8.1 times the cosine of 5.2. So I'm going to check my mode. It's in radian mode. That's good to go. So I have 8.1 times the cosine of 5.2. So x is about 3.79. And then we have y to be about negative 7 point, let's call it 7.16, and that should have been negative. Again, I encourage you to plot that. Where is 5.2 radians? Well, think about it. The circle has 2 pi radians. Pi is about 3, so it has almost 6 radians. So 5.2 radians would be in quadrant 4, which is where your x and y coordinate is as well.